In this video, we will do some derivative examples involving log functions. So I want to begin by recalling our formula for the derivative of ln of x. In the last video, we saw that this derivative was 1 over x. So what I want to start by doing now is finding what the derivative of ln of some more complicated stuff will be. Okay, and here I have an outside function, it's ln of x, and I have this inside thing, this stuff. So this is going to involve the chain rule. So this will involve chain rule. So let's explicitly write what our outside and inside functions are. So our outside function, and then we'll do inside function. Inside function. All right, maybe let's start with the inside function. And it's the stuff that's getting plugged in to the ln. So I'll call that function g of x, and g of x is the stuff. And that's getting plugged into this ln function. I'm going to call that f of x. So f of x equals ln of x. That is our outside function. So the chain rule says, okay, when you do this derivative, you should first get f prime, the derivative of the outside, but then keep plugging the same inside function into that. Keep plugging that stuff into it. So when I take the derivative of the outside thing, the ln of x, that's typically 1, oh, let me put it in gray. That's 1 over x. But the chain rule says, wait, don't write x there. Keep plugging in the stuff in for the x. So instead of writing x, I will write the stuff. I'm going to keep plugging the stuff in there. And then the chain rule says, okay, well then multiply that by the derivative of the inside, the derivative of the stuff. So we multiply by d dx of the stuff. All right, so I want to put a big old box around this because this is going to describe how we take the derivative of ln of some stuff using the chain rule. It's just going to be 1 over the stuff times the derivative of the stuff. All right, let's look at some examples. So I want to evaluate the derivatives of the following functions. So the first example has the function a of x equals ln of 8x to the third plus 1. Okay, so this isn't just ln of x, it's ln of some more complicated stuff. So this is going to involve chain rule. So my derivative, the chain rule says, okay, take the derivative of the outside thing, the ln, and that's typically 1 over x. But the chain rule says, well, don't plug in x, plug in the same stuff that's inside. That's going to be the 8x to the third plus 1. Okay, and then multiply by the derivative of that stuff. Multiply by the derivative of that inside stuff, that 8x to the third plus 1. Or as we saw in our general rule, the derivative of ln of some stuff is 1 over that stuff times the derivative of that stuff. Okay, so if I simplify and I do this derivative, the derivative of 8x to the third is 24x squared, and the derivative of 1 is going to be 0. And then when I multiply my fraction by that, it'll just come to the top. So I'll get 24x squared on top over this 8x to the third plus 1, and that is my a prime of x. All right, let's do example 2. So now we have h of t, and this is the quantity ln of t being cubed, and then times cosine of t. Okay, so to get this started, I have 2 functions being multiplied, so we need product rule. We will need product rule. At least first, we're going to need product rule. So when I do this derivative, product rule says take the first function, which is the quantity ln of t being cubed, times the derivative of the second. And the derivative of cosine is negative sine. So I get negative sine t. And then plus the second function, plus cosine of t, times the derivative of the first. So I'm going to leave myself a lot of room, kind of intentionally. Okay, so for the derivative of the first, I have some, it's not just t cubed, it's some stuff being cubed. So this whole thing is going to involve the chain rule. Chain rule for the derivative of the quantity ln of t being cubed. And the chain rule says, well, first deal with the outside thing, this power. And the power will come down. And I'll subtract 1 from the power, so that power becomes a 2. But when we do that, the chain rule says, well, keep plugging the same inside thing in. So keep plugging in ln of t. And then we do the chain rule step, in which now we multiply by the derivative of the inside. So the derivative of ln of t is 1 over t. And that is my derivative. So this is my derivative. All right, and I'm going to box this. The question didn't necessarily ask me to do anything to simplify further, so it's fine if I leave it like this. All right, so let's do example 3. So I'm slowly upping the difficulty on these. All right, so we have b of x equals 1 over this massive square root, inside of which we have ln of tangent of pi x plus arcsine of 2x. So the tangent and this arcsine are all inside. They're all inside that ln. All right, so before we get into this, I first want to recall what the derivative of arcsine is. So remember, the derivative of arcsine is just another way to say sine inverse. This was 1 over the square root of 1 minus x squared. So that's going to be important to us. I want to first give you 3 minutes to try this on your own. So pause it in 4, 3, 2, 1. Pause it and really try this problem for about 3 minutes. All right, so hopefully you did that. Let's talk about it together. So we want to begin by rewriting this. The square root, it's helpful to rewrite that as a power. It's the same thing as a 1/2 power. And when I bring that whole thing to the numerator, it will become a negative 1/2 power. So inside of that power, we have that ln of tangent of pi x plus arcsine of 2x. All right, so now when we start this derivative, when we're at b prime of x, what is that going to be equal to? Well, I deal with the outside thing first, which is this negative 1/2 power. That negative 1/2 is going to come down. And I'm going to leave a big old space here. And I subtract 1 from the power to make it a negative 3/2. And the chain rule says, okay, when you deal with that outside thing and you do its derivative, keep plugging the same inside thing in. So I'm going to keep plugging in this whole ln of tangent of pi x plus the arcsine of 2x. Okay, and then the chain rule says, well, multiply that by the derivative of the inside of this whole ln thing. Okay, and now we know how to do the derivative of ln of some stuff. It starts off, we're going to need another chain rule for that. It starts off with 1 over the stuff. Start off with 1 over the stuff, which is going to be 1 over all of this stuff inside the ln. So 1 over the tangent of pi x plus arcsine of 2x. We're going to start with that. Okay, so that is the 1 over the stuff. And then the chain rule says, okay, then multiply that by the derivative of the stuff. The derivative of this, everything inside of the ln. Okay, so I'm going to put that on the next line. All right, so I'm going to put a big old parentheses around the derivative of all of this stuff that's inside the ln. Okay, so the derivative of tangent of pi x. Well, that's going to be another chain rule, because it's not just tangent of x, it's tangent of some stuff. Okay, so derivative of the outside thing, this tangent is secant squared, and I keep plugging the same inside thing into it, the pi x. But then the chain rule says, okay, multiply that by the derivative of the inside. Derivative of pi x is pi. Okay, and then I go to the next term, the arcsine. And for arcsine, that derivative is the 1 over the square root. This is also going to be chain rule, because it's not just arcsine of x, it's arcsine of 2x. All right, so we'll have plus, when I do the derivative of the outside thing, the arcsine, we'll get 1 over the square root. And instead of 1 minus x squared, it's 1 minus the stuff squared. In this case, 1 minus 2x being squared. And then chain rule says, we'll multiply that by the derivative of the stuff, the 2x. And that derivative of that is 2. Okay, and then I close this parentheses, and then I close this bracket that I'd started. I'm now ready to close that. And that is my derivative. I just want to remember that this was when I was taking the derivative of ln of all of this stuff, that was 1 over the stuff, which I had here, and then I'm multiplying by the derivative of that stuff. All right, so let me box this. This was b prime of x. We needed a lot of room for this one. In terms of our goals for this section, we've actually now finished the first 2 goals. We know how to take the derivative of ln of x, ln of stuff, and we've done examples to combine that involve ln of x and combining it with other applications of the chain rule and the product and quotient rules.